All right, here we go. We're going to do electric forces one-dimensional here. So with one-dimensional forces, in general for forces, like signs will repel. So positive and positive will be a repelling force and opposites will attract to each other as a result. The formula for the electric or electrostatic force is KQ over R squared, where K is Coulomb's constant, Q1 and Q2 are the charges that we are comparing to each other for the force, and R is going to be the actual distance, radial distance between the two charges. So in terms of one dimension, a common question could be something along the lines of, go ahead and rank the following three or find the electric force on each of these stationary charges. So we have charge 1, charge 2, and charge 3, each a distance d of separation. So looking at charge 1, we're going to talk about the force from charge 2 and the force from charge 3. So here we go. For the first example, we're going to have, let's see, between charge 1 and charge 2, they're going to attract. So I'll call that F2 from charge 2. And negative positive will also attract. That'll be force 3. So for the force on charge number 1, the sum of the forces in the x direction would be force 2 plus force 3, because they're both going to the right. That would be from between 1 and 2, that'd be K. And we'll just assume it's either going to be a charge of a, Q or negative Q in this case. So I'm going to have K negative Q over D squared plus K negative Q over that total distance is 2D parentheses squared. So a little bit of algebra here. I'd factor out the Q because it'd be an absolute value. And then that would leave you with 1 over D squared plus 1 over square root 4D squared. So factor out the D squared, so that'll be Q is Q squared over D squared. 1 plus 1/4 is 5/4. So that'd be the answer for Q1. So I'm going to go ahead and kind of move all this over. Let's move that over here. Let's move it over here. So you got all that work recorded now. And so the force, the sum of the forces in this case ended up equaling KQ squared over D squared, and it was 5/4. Charge number 2. So now for charge number 2, negative positive is going to attract, so I'll call that force 1 from charge 1. Like charges will repel, so that'll be force 3 from charge 3. So the sum of the forces here in this case are going to be negative force 1 minus force 3. Why am I doing negative? Because on an x-axis, to the right is going to be adding, to the left is going to be subtracting, keeping a consistent coordinate system here because they are vectors. So that means we're going to have negative K between, let's see, between 1 and 2. So negative K, negative Q over D squared minus K between 2 and 3 for force 3, QQ over D squared. So that'll give you 2 of them. So negative 2 QQ, Q squared over D squared. If they want the magnitude, again, if they want the magnitude, then you take the absolute value. But otherwise, that's the net force. It's going to the left. So Q1 is going to be 5/4 KQ squared over D squared in the positive x direction. And charge 2 is going to be negative 2 KQ squared, over D squared. Update that. And that's going in the negative x direction. So let me go ahead and move all this out of the way now. Move out the way. You too. All your absolute value signs. What are you doing there? Go. Anyways, this is going to be negative 2KQ squared over D squared, or you could say it's 2KQ squared over D squared in the negative x direction. And then lastly, for charge 3. Q3. Okay. Between 1 and 3, they're going to attract, so I'll call that force 1. Between 2 and 3, they're going to repel. That's going to be force 2. So the sum of the forces in the x direction will be force 2 minus force 1. Again, why am I doing that? Because force 2 is going to the right, which means you're adding. Force 1 is going to the left, which means you're subtracting. To the right is positive, to the left is negative. Make sure you go back and watch how I did 1, 2, and 3 for those commonalities. So force 2 from charge 2. So that would be between these two is going to be KQ over D squared minus K between now 1 and 3. So it'll be KQ negative Q over 2D squared. So that's basically going to be KQ squared over D squared minus KQ squared over 4D squared. So to me, I'm looking at it as 1 minus 1/4, which is going to be 3/4 KQ squared over D squared. And that would, of course, since it's positive, the answer is in the positive x direction. If the final answer was negative, then it would be in the negative x direction. So there you go. And from there, if they want to rank, say, the magnitudes, if I'm looking at just the magnitude of each one of these, okay, then I would be comparing and saying, okay, well, the largest one would be 2, followed by 5 force, followed by 3 force from largest to smallest. If they want to do a whole ranking of, say, the force from charge number 2 is going to be the greatest, then it's going to be 1, and then it's going to be 3, ranking them for the total force from one charge based on the others.